All right, let's talk about SQL subqueries. You've been there, right? Staring at a query and every single subquery looks exactly the same? Well, you're not alone. It is a super common hurdle, but today we are going to clear it up for good. We're going to turn that confusion into some serious confidence, especially for that next big technical interview.
So really, why do they all look the same? I mean, it's a fair question. And the answer is, well, syntactically, they kind of do share a similar structure. You've got a query nested inside those parentheses, sitting inside a bigger query. But honestly, that's where the similarity ends. The real magic, the part that actually separates them, is what's happening on the inside.
And that brings us to the whole secret, really, the core idea of this entire explainer. There is just one simple rule to demystify every subquery you'll ever see. It all, and I mean all, comes down to two things: what the inner query returns, and then how the outer query is built to use that specific result. That's it. Seriously, that's the key.
Okay, so let's really dig into this simple rule. From now on, whenever you see a subquery, I want you to just stop for a second and ask yourself this one simple question. What does this inner query actually return? The answer, you'll see, will immediately tell you exactly what kind of subquery you're looking at.
And you know what? There are really only four possible answers to that question. It can return a single value, right, like an average or a max price. It can spit out a list of values in one column, maybe a list of user IDs. It could return a combination of values across multiple columns, like a whole row pattern. Or, and this is the special one, the value it returns can actually depend on the row it's currently processing in the outer query. Let's break these down one by one.
So let's start with the two you're going to see most often: scalar and column subqueries. The key difference here is super simple. Are we getting back one single number, or are we getting back a whole list of them? First up is the scalar subquery. Now, scalar sounds kind of fancy, but it's really just a word for a single value. That's all. This subquery returns exactly one row and one column. Think of it like this. It's taking a whole table of data or some complex calculation and just boiling it all down to one single definitive number. So, here's the part that's going to make this click: the mental model. For a scalar subquery, I want you to think, I need to compare everyone against one specific number. This could be the average salary, the maximum sale price, whatever. It's always a one-to-many comparison against a single benchmark.
Okay, let's see how this actually works. Look at this example. The inner query, the part in the parentheses, it runs first. It calculates the average salary for all employees, and poof, it returns just one number. Then, the outer query takes that single number and uses it to find all the employees whose salary is greater than that average. See? Simple, clean, and really powerful.
All right, for your interviews, you're going to want to lock these keywords in. Scalar subqueries almost always use those simple comparison operators: equals, greater than, less than. And they're usually powered by aggregate functions like AVG, max, or min. Now here's the critical constraint, the thing you can't forget. It absolutely must return only one value. If it returns more, your query's going to crash and burn with an error.
Okay, so that's a single value. But what if the inner query returns more than one row but still just one column? Well, that's our next type, a column subquery. Instead of one single value, it hands you back a whole list of values.
And this brings us to a whole new mental model. Here, you're not comparing against one number anymore. You're checking for membership. The question completely changes. It becomes, is the value from my outer query present anywhere inside this list that my inner query just generated?
Here's a perfect example of that. Check it out. The inner query runs and finds all the department IDs for departments located in India. It returns a list of those IDs, right? Then, the outer query uses the in operator to select all the employees whose department ID shows up in that specific list. It's just a pure membership check.
So your interview keywords for column subqueries, they're all about in and not in. These are the operators designed to work with lists. And just like our scalar friend had a critical constraint, the column subquery's big rule is that it can only, and I mean only, return a single column. Okay, let's take a breath. We're moving on to the more advanced types now: row and correlated subqueries. This is where things get really interesting. We're moving beyond single values and simple lists, and we're getting into matching entire patterns and creating these dynamic row-by-row calculations.
So, a row subquery, what is that? It's what you use when a whole combination of values in a row matters. Instead of returning just one column, it returns multiple columns. Think of it like this.
You're no longer just checking if an ID is in a list. You're checking if an entire combination, like a customer ID and an order date, matches a full row in your subquery's result.
So the mental model has to shift again. You got to think, match this whole row pattern, or this whole tuple of values if you want to get technical. This is so important for finding things like the very latest order for each customer, or the employee with the highest salary in each department. These are super common, really practical tasks you'll do all the time.
All right, now for the one that often trips people up, the correlated subquery. So what makes this one so special, so different? It's this. The inner query is not independent anymore. It actually depends on and uses values from the current row that the outer query is processing. There's a direct link, a correlation between the two.
So the mental model here is fundamentally different from everything else. You have to think, for this specific row in the outer query, right now, I need to run my inner query to calculate a value that is totally unique to this row. So for example, for this one customer, what was the date of their very first order? The inner query has to execute again and again and again, once for every single row in the outer query.
And that brings us directly to your interview keywords. You absolutely have to mention that it runs per row. This is what makes it so powerful, but it's also what makes it potentially expensive or slow, especially on big data sets. And here's the pro tip, what a senior would say. Mention that its logic can often be rewritten way more efficiently using a join or a window function. Okay, let's switch gears a little bit and talk about a really special case, the exists operator. It uses a subquery, sure, but its purpose is completely different from everything we've talked about so far. With exists, we honestly don't care about the actual values being returned. Not at all. The mental model for exists is just pure true or false. It's a Boolean check. It asks one simple question. For the current row I'm on in the outer query, does my subquery find at least one matching row? Yes or no? That's it. It's not returning data, it's just returning a thumbs up or a thumbs down.
And this brings us to a classic interview question. In versus exists. Now, while in is comparing the actual values from a list, exists is just checking for the presence of a row. This is a huge deal, because it's why exists is often so much faster. It can stop searching the moment it finds the very first match. It short circuits. Another key difference is how they handle nulls. Exists can work just fine with nulls, but in can get weird. Knowing this distinction is a huge plus in an interview.
Okay, so we've pretty much mastered the what. Now let's talk about the when. When should you actually use a subquery, and when is a join the better, more professional choice? Answering this well is what really separates a junior from a senior data pro.
Look, subqueries can be incredibly easy to read, especially for simple, nested logic. It's often just easier to think through a problem step by step that way. But, and this is a big but, when it comes to performance and scalability, especially in a real production data pipeline, joins are almost always going to be preferred by the database's brain. They are just built from the ground up to relate large data sets efficiently.
And that brings us to this power phrase. You got to remember this for your next interview. Saying something like, I can write this with a subquery for clarity, but in a production environment, I definitely use a join for better performance. Wow. That shows you don't just know the syntax, it shows you understand the practical, real-world trade-offs. It shows you think like an engineer.
Okay, let's do one final rapid-fire recap to lock it all in. If you remember nothing else, remember these mental models. Ready? Scalar, one number. Column, a list. Row, a pattern or a tuple. Correlated, that's your per row logic. And exists, a simple yes or no check. Got it? Awesome.
And that's it. You now have the framework to look at any subquery and know exactly what's going on. So, what's your next move? Look, the best way to make this stuff stick is to practice. Seriously. Go try to write one example of each type we covered today. And if you want a real challenge, take that correlated subquery example and see if you can rewrite it using a join. That right there, that's how you build real-world data skills. Happy querying!